All right, so boys and girls, the next video, we're going to continue talking about friction and remembering that one kind of friction is air resistance, right? And so this is one of my favorite ideas here. You're getting ready to watch a video, and in this video, there is a ball that's much heavier, and it's going to be dropped at the exact same time by a very precise machine at NASA. And dropped at the same time, and then we'll be able to predict which one we think will fall first, right? So then as you watch the video, you're realizing that the video is taking place in what is called a vacuum. Now, this is not the kind of vacuum like vacuuming your house, but kind of like that, because when you vacuum your house, you're sucking up all the dirt and debris into the canister of your vacuum cleaner. Well, in science and in space, a vacuum is when all of the air has been taken out. You may have seen this like on TV with like vacuum sealed plastic bags where they put like their blankets and stuff into a plastic bag, and then you attach a vacuum cleaner to suck the air out of it, and it squishes everything out as it sucks out the air molecules. Yeah, that would be a vacuum seal. You probably have also ordered something from Amazon, maybe, that was vacuum sealed, and when you open the package, it goes and fills back up with air like that. Vacuums are when you don't have any air. So in space, we consider it a vacuum. You don't have the air molecules. And remember, we said that things that are flying around in space are a good example of Newton's first law, that an object in motion will stay in motion, because objects in space keep on moving until they bang into something else, because there is not air molecules in order to slow them down with air resistance. All right, so this video is really, really cool. And I'm going to try not to talk too much about it, but let's watch together and I'll say what I got to say if I got to say something. Now notice, right? A feather would not normally fall at the same time as a heavy ball, just like the ball of paper that was squished up fell faster than the flat piece of paper, right? But remember that air resistance, right, would be the thing that slows things down. And remember, I said this is a vacuum chamber. So let's watch.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air. Galileo's experiment was simple. He took a heavy object,
and I don't know if I've said this before, but I feel like it was in one of like the brain pops that Sir Isaac Newton got his ideas from Galileo and experimented on them. So Galileo was an ancient science dude that thought of lots of deep thoughts with regard to science. And then when Sir Isaac Newton came along, then he moved even further with those thoughts. And then Einstein even moved further within Sir Isaac Newton with some of the same concepts. So Galileo is the really old guy from like, I don't know, centuries, no, millennium ago, I think. I think he's pretty old, from a long, long, long time ago. I have to go look it up to find out exactly how long ago Galileo was.
And a light one, and dropped them at the same time to see which fell fastest.
Right? Normally, a bowling ball would fall faster than feathers.
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
Okay, we dropped 2 Militor in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
This is cool, y'all. They're taking literally every molecule of air out of this vacuum chamber, right? So there's no air resistance whatsoever, just like in space. Cool.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1, release.
It's pure gravity with no other force interfering.
Yeah.
Exactly.
Look at that.
They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Isn't that crazy? Like, this is such a good example to be able to see what air resistance does and how much friction comes from just the air, right? Like, if no air was there, then feathers would fall at the same rate as bowling balls. That is nuts.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity.
Gravity pulls down, down, down.
But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all.
What?
He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the earth.
Wait, he's saying if you couldn't see the background, there would be no way of knowing that they were falling to the earth. All right, now this is messing me up, y'all.
So he concluded they weren't.
Okay, forget that part, y'all, because everything else is cool. But yeah, we need to be thinking about that a little bit deeper. And I'm gonna stop this now.
Next time you do this,
And I guess the thing is to think about, do you agree that things weren't really falling to the earth and there really is no gravity? No. Right? No. Freaky. Okay. Bye, y'all.